like climate change, yoga, artificial intelligence, and other things. And in this series, we have organized 8 webinars, and some of you have been attending all the 7 earlier. The final one is on artificial intelligence. We started with yoga, linked with human intelligence, and we are ending up this webinar series with artificial intelligence. And for this webinar, to deliver the thematic address, we have a very eminent, very distinguished scientist, an IT person from Cochin University of Science and Technology, CUSAT, Dr. G. Santosh Kumar, a professor of computer science and the director of the Center for Information Resource Management of Cochin University of Science and Technology, which is taking care of the entire network, e-learning, and all the IT services of the entire campus. And some of you who might have gone to CUSAT, you know the magnitude of the campus and the work that Center for Information Resource Management is doing. And Professor Santosh is an MSc Physics, MPhil Physics with an MTech in Computer and Information Science and a PhD in Computer Science and Technology. And he is one person, a blend of academic brilliance and technical know-how, a person with a huge experience in the academic side as well as the industry side. Before joining the academia, he was earlier with Tower Information Technology as senior analyst programmer, and before that he was an analyst programmer, and he worked for the research and development division of Fujitsu Japan in Malaysia. And his research areas and interests are cyber physical systems, computer vision, data science, and natural language processing. And he has been the chairman, Board of Studies, Computer Science, and head of the Department of Computer Science at Cochin University of Science and Technology. And importantly, he has held the membership of the Board of Governance and Executive Committee of the Center for Digital Imaging Technology, Thiruvananthapuram, CDIT, and he has been a member of the Senate, Board of Studies, and a variety of other administrative bodies in Cochin University of Science and Technology and other academic institutions across the country. And he was also the chair of the IEEE Kochi division, and he has organized IEEE international conferences very religiously for many years, every year. And on his research side, he is one person with a very huge funding, right, to the tune of about 4 crore 50 lakh worth project, ongoing project with NTNU Norway, Hainan University, and China, University of Pennsylvania, USA, and University of Aizu, Japan, a multi-country project. And he is also the project investigator of Spark project of MHRD, where the main partner is IIIT Delhi, and other partners are Queen's University, Belfast, United Kingdom, and NTU, Nanyang Technological University, Singapore, and which is also an ongoing project. And he has completed a DST funded FIST program at the Department of Computer Science also. And he has been delivering a lot of invited talks on a variety of interesting applications of IT for the human benefits. And of course, he is a regular contributor to our HRDC as a resource person. And very happy to say that we have shared a number of platforms. We have conducted a lot of workshops together on Web 2.0, virtual learning, and learning management systems and other things. And of course, artificial intelligence is a theme worthy of a refresher course for 2 weeks. So, but he is here to speak to you about its applications on a variety of fronts in the given 1 hour and 20 minutes also. The last 10 or 15 minutes can be for discussion. So without taking much of time of Professor Santosh Kumar, I once again take immense pleasure and pride in welcoming him on behalf of Bharatdasan University and the HRDC, right, and on behalf of all of you also. And I'm sure you will really enjoy interacting with him and getting to know from him how this artificial intelligence is going to make a lot of difference in the days to come. Even in the national education policy, there is a lot of talk about it, right? How this artificial intelligence, virtual reality, augmented reality, and a couple of other technologies together are going to make a lot of difference to human lives in the next 50 years. It is not that one particular area gets touched and the other things remain aloof. It is ultimately going to be the human life getting the touch and benefit of this artificial intelligence application. So he is going to throw more light on that. I'm sure you will find the session interesting. So it is over to you, Dr. Santosh. It's a great pleasure having you with us this morning. And we have participants from Madurai to Noida, from Jabalpur, from very many parts of Nashik, very many places of North India to Kanyakumari. We have people. So I'm sure you will. In fact, for this particular webinar, we had some 1,100 plus registrations. So we even have participants from Jharkhand and Himachal. So we have allowed only 250 people to participate in this Google Meet, which the enterprise account provides. And the others, we have planned to share the video links with them for the benefit of them. Right? So with this brief words of introduction, let me hand over the session to Dr. Santosh for interacting with you all. Right. So thank you very much, Santosh. It's over to you. Right?
Yeah. Thank you, Dr. Senthilnathan, for your nice and very interesting kind of an introduction. I really enjoyed it. And good morning to all of the participants who are very much keen in listening to what is basically AI and how AI is going to or changing our life, and as a responsible human being, what we can contribute in this area. So first of all, thanks to the HRDC Center of BDU, Bhadridasan University, for inviting me and allowing me to interact with such a spectrum of people. So as requested by the director, I'll be touching upon general aspects of artificial intelligence as a whole. What is its story behind AI, and some of the interesting applications that AI has already been starting to change our lives, and the upcoming challenges that this field is actually offering. So those things we will be trying to discuss, and I'll be happy to take any questions at the end of the session. So I'll be stopping at least 10 to 20 minutes before my allotted time. So I request you to put your questions in the chat box, and request someone to take it and read it for me, so that I can answer most of the questions very quickly. So thank you. So welcome you to my presentation on AI for all. So that's what the topic given to me. So let's begin with the agenda item. So I'll be talking about the history of AI, because if we wanted to digest something, anything, right, we must know the history, how this field has been evolved, who were the key persons who contributed it, and what is actually envisaged by these people, and what we are actually trying now enjoying it, right? Then some kind of definitions related to the field AI. There are a lot of technical words associated with the word artificial intelligence. I know the participants are from different subject areas, so I would like to give a kind of a running kind of a definition so that everyone can understand it. I won't go into the technical details of it. Then as everyone is interested, I will try to illustrate some of the techniques which is used for machine learning and ultimately achieving artificial intelligence. Then very interesting applications I will try to demonstrate. Then I will talk a little bit on responsible AI, where maybe the whole world is actually concerned about driving AI into a responsible kind of technology. Then those who are interested in pursue further, I'll be giving some references, pointers, some courses and books and all. Then I will conclude with question and answer session. So this is the agenda of my talk. So without mentioning Alan Turing, we cannot move further, because he is considered as the most prominent person and considered among the founding fathers of artificial intelligence. So as you know, the year is 1950. So he was very much interested in developing computers, and he came up with even a detailed circuit diagram and even the cost of producing a computer at that time, right? And at the same time, he has written a paper, Computing Machinery and Intelligence, in a journal called Machine Mind. And in that paper, he was keen to ask a question: can machines think? So this was the first question in the history of computers, and maybe the advances that we have seen was asked: can machines think? Right? So as you all know, computers actually were considered as a dumb kind of a machine, where we have to do some programming, right? So most of the applications that you are using is a kind of a application software which is written in a software programming language, and then it is compiled and it is made as an executable kind of a stuff, so that once you double click an icon, that application will pop up, and you can do or you can use that application, right? So for example, think of a calculator kind of a program. Everybody might have used a calculator, right? So calculator is a device, a program which is used to compute just numerical equations or mathematical stuff we wanted to compute using that software, right? So this software is designed by somebody, right, and programmed by a team of people, and then made it as a software, so that we can install it in a computer, and the end users can use that software. So the important thing is, the calculator is a program where we actually has told the machine to do a number of steps, right, in order to execute whatever the input that has been given to that software. For example, suppose we are typing 100 minus 75 equal to what, right? So then it has to take those inputs, and it has to go to a logic where it is been written by a software, where we have to take the difference from 100 to 75, and we have to produce a result, right? So whatever the user is asking, the program is giving us an output, right? And the calculator itself doesn't have any thinking capability, right? So you have to say 100, then you have to press a minus symbol, right? Then the next value 75, right? Then you have to say equal to, right? Then only it will show the results corresponding to that. So it is a dumb kind of a software. That means it doesn't have intelligence of its own, right? It's a software, and most of the software that we are using doesn't have intelligence, right? So basically, the Turing's question was, can machines think, right? So that means maybe can computer take some input and maybe manipulate by its own, right, to produce some kind of a result, right? So that was the question, and it went to a famous test called the Turing test. Right? So I will explain what is a Turing test first, because if anybody is asking you whether this program is having some intelligence or is it an artificial intelligence program, then you may have to ask him whether it passes Turing test, right? Turing test is very simple. Basically, you have 3 persons in this test, right? So one person, a human being, right? Another person is considered as a machine, right? And which is actually separated by a wall, and the other side of the wall, another person is sitting, right? So 2 human beings and 1 computer, right? 2 human beings sitting at the different side of the wall, and 1 human being is sitting along with a computer, right? So what they do, basically, the human being sitting behind the wall, he will write something, right? He will transmit a text, a question. For example, how are you doing? Right? It's a question. It's a question written in English sentence, and it is passed to the wall, right? And from the wall, the human being or the computer will take that question, right? And after some point, he will get an answer corresponding to that question, right? So what is the Turing test? Turing test is, so once the human is getting an answer from the wall, behind the wall, whether he can identify, right, the answer is coming from a machine or a human being, right? If he can identify whether it is coming from a machine or human being, then the application has failed the Turing test. If the answer is not distinguishable, that means the human being sitting behind the wall doesn't know, actually, he is not able to figure out whether it is coming from a human being or a machine, then you can say that that computer has some bit of intelligence, right? So this is the famous test that will be used to identify whether a human being or a machine is actually interacting with the person, right? So this is the famous Turing test proposed by Alan Turing. Another person that I just wanted to introduce you is John McCarthy. He is the again considered as founding fathers of artificial. The word artificial intelligence in 1955. Basically, he has convened a conference in Dartmouth, US, and he asked to most of the scientists who are working in this area asked to join this conference and discuss, right? So he wrote a paper in 1960 with title "Programs with Common Sense," right? So please make a note that this is year 1995 and 1955 and 1960, right? So at that time itself, people were asking whether the machine can have some intelligence or whether the machines can, whether programs can have some common sense, right? So this is these are the persons who actually attended that conference. So you can see John McCarthy there, and Marvin Minsky is another person, a key person who has actually contributed a lot in the development of artificial intelligence. And the third person, you know, many of you might have known this name, Claude Shannon. He is the father of information, basically information theory, where most of the electrical engineers and electronics and computer science people learn theory of information, right? And there are a lot of other people who have contributed, and these people are actually known as founding fathers of AI. Another key person in this is Arthur Samuel. So basically, what was his contribution? He actually maybe come up with an idea where a program can play a chess game, right? So he has written the first ever checker program. Checker is basically a chess program. So he has invited, at those times, the Russians were basically chess masters. They were considered as chess masters. And he has invited 4 key persons to play a chess game simultaneously with a computer, right? So the other end, computer was playing or moving the chess coins, and the other end, the human being were actually moving the chess coins. So he actually developed the first ever maybe a program which can simulate the chess game, right? So, and this is considered as the first machine learning kind of a program. So Arthur Samuel is considered as the founding father of the field called machine learning, right? And another person, which is none other than Frank Rosenblatt, he actually tried to put forward a concept of what we call perceptrons. So, which is something similar to the neurons that is there in a human brain, right? So, as you might be knowing, human brain is basically consisting of a huge number of neurons, right? So 10 to the power of 11, it is considered as 10 to the power of 11. That means 1 followed by 11 zeros. That much number of neurons is there in our human brain. And these neurons are making interconnections, right? While we are thinking, while we are doing something, while we are sleeping, right? Most of the times, these neurons are actually trying to make connections, and maybe people work based on those type of connections, right? Suppose we are thinking about a friend, right? So the friend's face will appear in our mind, right? So that is only because the brain is actually activating some of the neurons which are connected with this friend, right? Or some instance related to that friend, and these connections actually comes in our memory, and those connections makes a kind of a network, and this network is actually trying to give an image of this person, right? So this Rosenwald introduced the concept of perceptrons, and he tried to make these perceptrons in the machines, right? So in machines, is it possible to build perceptrons and try to mimic how the brain is actually operating inside the machine, right? So this work actually contributed a lot in the recent developments of machine learning, artificial intelligence, and deep learning, right? And please make a note, this is 1962, right? Now, let us formally try to understand what is basically artificial intelligence is, right? The ability of a machine to think more like a human, right? So this is the proposed idea, right? It has to mimic the functions of human brain. It doesn't mean that you have to build a machine which is similar to human brain. It's not like that. It is like how human beings are working in a similar way, a machine must be able to work, right? So in this scenario, I just wanted to introduce two pertaining ideas, which is called weak AI and strong AI. Weak AI is weak artificial intelligence, and strong AI is strong artificial intelligence. And strong artificial intelligence is related to the ability to think, right? And weak AI is basically simulating, and the thinking process is being simulated using weak AI, right? And currently, we are in a position to have a lot of applications which are related to weak AI. and not strong AI, right? So ability to think is yet to achieve. We are not at to that point, right? But we have very much wonderful applications at our hand. And people will ask, what is machine learning then, right? So machine learning is a subset of AI, right? The machine learning contains within the field of AI, right? So basically, it is being used to, it is a technique basically to process huge amount of data and provide a feedback based on the information gathered, right? This is a key part because most of the people or human beings starts learning with a feedback, right? So a small child starts walking. So before walking, he will fall down, right, several times. But he will again start try to maybe wake up from there and then try to move forward, right? So this type of feedback is actually required to learn something. So machine learning is a subset of AI which is actually related to processing large amounts of data, and the feedback basically the algorithms which implements machine learning will give you feedback so that it tries to learn something. So the word learning is basically coming from the processing of data and then getting a feedback to get some information from that processing, right? And again, another word is neural network. Neural network is, as I just explained to you, it's a mathematical model that use learning algorithms, right? So it is inspired from the brain to store information, right? And we are using it in a machine. We call it as artificial neural network, right? So the neural network implementations inside a computer is known as artificial neural network, right? So let us see just a small architecture of a neural network, right? An artificial neural network. So basically these dots, right? These dots are basically, you can call it as neurons, artificial neurons, right? So these are these are input layer. So when you hear about artificial neural network, it consists of multiple layers, right? This is the simplest artificial neural network where we have input layer. So these green dots are input layer, and these light blue dots are called as hidden layers, and this purple dot is called an output layer, right? So here basically the machine is able to get some input to these green neurons, right? It does some operation on these and it passes to the neurons that is there in the hidden layer, right? So what is the process that is happening here, right? So the process that is happening here is basically you will have some weights associated with this, right? Weights associated with all these input neurons, and this will be passed to this, right? It does some operations, right? And then it passes to the output layer. So we have an output here, right? I will explain this with an example very soon, right? So for time being, just consider we have an artificial neural network, which is nothing but the neurons interconnected, and we have an input layer, a hidden layer, and an output layer. So this is the architecture of an artificial neural network, right? So I would like to just tell you the history, and during 60s and 70s, basically a lot of work has went, right? But after that, a lot of maybe people were not able to work in this area, and people got desperate, and we call this as AI winter, right? So in 1973, it started maybe not many people were actually interested in doing work in there. And then 80s, some work has happened. Then again, in 88, there were a lot of problems with the thing, and it remained like that. And you see, in 2012 only, a revolution happened in this area. So why this gap was there, right? So we will see that because of scarcity in availability of data and the processing power. So these were the two major blocks at that time we had. We didn't have much computation power to process data, and again we were not able to get huge amount of data to process, right? So this was the reason for the winter, AI winter, right? But in 2012 it started picking up because of availability of huge amount of data, right? And availability of the computation power. I will explain that in a moment. So deep learning is another word which is again we consider it as a subfield of machine learning, right? Which attempts to imitate the interconnectedness of human brain using neural networks. I told you in human brain, basically each neurons tries to connect to the other neurons and connects a kind of a network, right? So that kind of a network is actually required to process something, right? And deep learning tries to mimic the same idea with the help of artificial neural network that I have shown, but with lot of layers. So in the previous diagram, what we have seen was actually one input layer, one hidden layer, and another output layer. But here you can see a deep neural network will have multiple layers of hidden layers, right? Multiple hidden layers it will have. So these green dots, it's not three actually, it is a huge number of layers. It might be 1,000 maybe layers, right? So input layer, then huge number of hidden layers, and then we have a set of output layer, right? So this is the architecture of a deep neural network, right? So far I have told you some words related to artificial intelligence. I told you machine learning. I told you neural networks. I told you deep learning. Now we can digest it like this Russian doll kind of a thing, right? So this deep learning doll is a small doll. You can put this doll inside this neural network doll, right? And neural network doll, you can put it into machine learning doll, and machine learning doll itself, you can put it into artificial intelligence. So what is the message? Artificial intelligence is a larger area, a subset is machine learning, and its subset, right? Machine learning subset is a neural network area, and neural networks subset is a deep learning area. So this image tells you the entire story of artificial intelligence. Now you must be able to answer a question. So what is artificial intelligence and what is deep learning, right? You can very well say that deep learning is a subset of artificial intelligence, and deep learning is a required technology to achieve artificial intelligence, right? So as I told you, data and computing power, right, is basically generating AI models, right? So this term we have to understand very clearly what is meant by artificial intelligence model, right? So from the data and the computing power, we are able to try to build models, right? So data, from where data is coming? From anywhere, right? So after the explosion of internet, right, huge amount of data is available. After maybe 1995 onwards, right, the internet was there, the Google search engine was there, right? After that, people started the social networking networks, etc. Huge amount of data is being generated. Billion, trillion gigabytes of data has been generated in each moment actually, right? Everybody is chatting, everybody is posting, right, in their social network platforms. Huge amount of video files, images, text, etc., has been generated, and from other transport industry, for example, right? Then geographical information is there, scientific, right? Health information is there, financial information is coming, statistical information, meteorological information. A lot of information are available now, and we call this as the huge amount of data that we wanted to process, right? And you know, the machine, the capability of machines, basically we have this is a simple machine around 2 crores rupees worth, right? So this is NVIDIA's DGX A100 machine. So basically we have a technology called GPUs, graphical processing units. In computers, you are familiar with CPUs, right? Central processing units. But nowadays, most of the computations can be done using another processor, a set of processors, which are called GPUs, graphical processing units, right? So these processors are actually having huge number of cores. So why cores are important? So you can parallelize, right? A task can be parallelized. You can execute in a parallel manner if you have more number of cores. So that is the message. So if you have more number of GPUs, you can parallelize your work. That means you can process a huge information within no time if you have more number of cores, right? And you can see that it can produce 2.5 petaflops of computing power, right? So in an organization, you can buy this and you can try a lot of AI related problems, right? So a QSAT like university definitely are procuring these type of machines for processing a huge number of information, and that is to benefit our research scholars, right? So this data, huge amount of data and huge computation power had enabled the progress in artificial intelligence and machine learning, right? So as I just pointed out, there are weak format of AI and strong format of AI. So another name for this is artificial narrow intelligence, right? So this is a weak AI, narrow intelligence. Then we have a strong AI forms. One is artificial general intelligence and artificial super intelligence, right? These are strong AI. So narrow intelligence means basically we can execute some predefined type of a task, right? So for example, you are familiar with Google Translate, right? You give an input language and it will produce an output text in the given language. So for example, if you are giving a set of English words, and we can convert that into a Tamil kind of a text, right? And why it is called narrow intelligence? Because it is tuned for only for this program is only for translation, right? It can translate multiple languages, but it is only used for translation, right? But on the other hand, if we say that general intelligence means the same program can do multiple tasks, right? Like our human brain. We can cook, right? We can design a recipe and we can make a very delicious dish in our kitchen, right? Then we can repair some electronic gadgets, right? We can read newspapers, everything we can do. So this is called a general kind of an intelligence. And we are not actually reached at that point, right? And another thing is maybe a fictitious kind of sci-fi movies you might have seen, super intelligence. That means, so once machines achieve general intelligence, that means machines are working at par with the human being. After that, what happens, right? After that, people think that machine will go beyond, right? Like Rajnikant's movies, right? You might have heard Yantiran, right? So after, at some point, it tries to go beyond human intelligence. So that is what is called artificial super intelligence, we need not worry about this, right? We are not at even general intelligence, right? We are at narrow intelligence only. So we are actually seeing a lot of applications which are built based on weak AI, right? So don't be afraid of hearing that, okay, maybe 5 years down the line, robots will come and acquire the entire universe, right? Don't worry about that. It will take a lot of time, right? So a lot of examples, right? Generally, we are hearing self-driving cars. Even in India is about to ban such self-driving cars, but a lot of other countries actually are enjoying this type of driving cars. For example, in Singapore, you can use an app and you can book Uber car, so that a Uber car will come without a driver, and you can tell the location where you wanted to go, and the car will safely drop you there, right? And you know, Google has given Google and Stanford University has done a lot of work in this to make self-driving cars possible, right? And many motor companies, right? Motor companies like GM, Ford, etc. A lot of people are actually working in this area, and a lot of instances are actually already there in the on the roads, right? Then speech recognition, right? Like your Google Assistant, right? In Android phones, or Siri in your Apple phones, right? So a lot of chatbots are already available, and you can just speak something so that they can execute the task for you, right? So call my friend Murugesan means it will take the number of Murugesan and it will call Murugesan, right? So chatbots are there, right? So there are a lot of websites nowadays install chatbots, like maybe IRCTC website. You might have seen one chatbot called Disha, where you just type some questions, maybe it will try to give you an answer, right? But the answers may not be that much promising now, but later, as and when it gets lot of data, maybe it will improve on that, right? So all these applications will have AI model, right? AI model, we haven't seen what is it, but we will see with an example, right? So AI models, that is working for you, right? And pattern recognition, a lot of work in computer vision related things, medical image domain has happened. So for example, suppose a doctor is wanted to diagnose some disease from a CT image, right? Or an X-ray image, right? So this image can be given as an input to a computer, and a model that is already been learned can take this image, and it can spot whether it is having a disease or not, right? So these type of applications are already there. Then in computer programming, basically I have seen one very interesting application where computer programmers, start writing some code, right? So if you give a small skeleton of code, there are programs which will complete that code, right? So you give some small hints, then automatically it will suggest a code, and most probably that is the code that you actually wanted to write, right? So this type of applications are there, right? Then image recognition kind of a software, you already know Google has a reverse image search, right? Google image search, if you go there and you just input an image, it will show, right? It will show if that image is there, right? Or it will show a similar type of images, right? It will show all the stories related to that image, right? You can try that. You can upload your own image and just try, right? Just go to the Google image search, right? So basically, it is a reverse image search. You are giving an image, right? And Google is trying to check a similar type of an image from the huge database that is already built in, right? Then recommendations, right? Maybe if you do Amazon kind of order, right? So you procured something in the last week, some related things will be again coming to you, right? And even if you browse something, some kind of an advertisement will come, right? These are all recommendation systems, right? Netflix, if you go to Netflix and watch a movie, maybe a kind of a sci-fi movie, then most of the sci-fi movies that is available in Netflix will be recommended for you, right? So it tries to understand you, right, based on your interaction with that machine, and tries to recommend it. So recommendation system is again an artificial intelligence related program, right? Then fact checking. So nowadays a lot of fake news is coming, right? A lot of fake news is spread through all the possible social media things, right? And excuse me. Excuse me. Okay. Okay. So a lot of fake kind of news, and machines are now intelligent. Now they can identify a piece of news item and it can figure out whether it is a fake news or not. So there are a lot of different varieties of methods basically used to identify whether it's a fake or legitimate kind of a news, right? Okay, so now we can take a small break and we can see how a machine actually learns, right? So far the story was, I just introduced you what is basically the history of AI, what are the key terms that is there in AI, right? And then I have just described what are the kind of applications that is there in the field of AI or machine learning, right? So this is for the introduction part. Now we are going to learn basically not that much technically, but just to understand how a machine actually learns, right? So if you are ready, we can go for that. So this is the problem, right? So a computer is given with an image of an apple and an orange, right? So the task is the machine has to tell whether it is an apple or orange, right? So how we are going about solving this problem, right?
Based
So
on the
people will
attributes.
think, yeah. So people will readily think that okay, now apple has color red, right, and orange has a color maybe yellow, right, or orange, right, and from
Comparing the
image,
features.
yeah, please, yeah. So comparing the features, we can basically learn whether it is an apple and orange. So by looking at, you might be thinking about the shape of the object, right? It is round in round shape may not be a discriminating feature, right? So discriminating feature means you must be able to surely distinguish between these two objects, right? So color might be a distinguishing feature, but there might be some apples, right, which will have orange. I'm sorry, somebody wanted to. Okay. Okay. So the round shape may not be a discriminating feature, right? Because most of the apples and oranges are having a similar kind of thing. What about weight? Right? Weight could be a discriminating feature, or the texture, right? By just touching the apple, you can readily say that it is apple, and touching an orange also, you will be able to say that it is orange because it is having a bumpy kind of a texture, right? So you can think of n number of features based on the objects, right? But suppose I have a black and white image given to the computer, right? Then color may not be a discriminating feature because all are grayscale, right? So distinguishing the discriminating feature is very important once you try to solve similar type of problems, right? So let us see how we can solve this. So basically what we are trying to do is a learning method which is called supervised learning, right? Supervised means we teach the machine, right? We are giving a lot of instances, similar instances, and tell the machine that this is an apple, this is an orange, this is another apple, this is another orange, right? Lot of instances we are giving, and these instances basically we call this as labeled images, right? So label. So we have a label associated with the object. So apple, we say that this is apple. Orange, we say that this is orange, right? So labels are associated with this, and we teach the machine, right? So what we are teaching, basically we are teaching to learn a function. Maybe mathematicians will know what is a function, but for the sake of understanding, let's say it's a mathematical kind of a object, which we call it as a classifier, right? So a classifier is being learned. What classifier does? Classifier does nothing but classifying it to class 1 or class 2, right? So you give apple as an input, right? It says that apple belongs to class 1. You give an orange, right? It says that orange belongs to class 2. That's it, right? So what we have to do is we have to create a classifier by finding patterns in the examples, right? Finding the features that is there in the examples, right? So supervised learning, right? So what is the recipe for supervised learning? We have to collect training data. See, we have agreed that we are going to teach the machine, right? So teaching is basically a process which is called training. We are training that, we are going to train the machine. So for that, we have to collect a lot of data, right? Why a lot of data? Because we don't know what kind of a shape, what kind of a color is there for an orange or an apple in the entire universe, right? We wanted to we wanted to teach the machine whatever type of an apple, whatever type of an orange comes, you should tell whether it is apple or orange, right? So for that, we have to have a lot of data, right? What is the data here? Data of the images of orange and apple, right? So you collect the data and train the classifier, right? I haven't told you anything about classifier, but we will see that what is a classifier. Then make predictions. So this process is basically, we call it as a machine learning pipeline, right? The word pipeline is basically from the input, how you produce output. So what are the intermediate processes that you are going through? So this is called a machine learning pipeline, right? So collecting data, training the classifier, and making the predictions. So this is basically a recipe for supervised learning. Now you see the discriminators. So we have already discussed the features, right? The discriminators are basically the features related to this problem. So it could be color, it could be texture, it could be shape, it could be smell, right? It has a core, right? Or what is its weight, etc., etc. A lot of features you can consider, and you can produce the target kind of thing. The target is just nothing but the label that we are going to produce, whether it is an apple or orange, right? So I'm just giving you a very simple table where I just took two features, right? Weight and the texture, and I have already labeled it, right? So this is the training data. Training data means I already know what is it, right? So weight of the object is 150 grams, and the texture is bumpy kind of a thing, and the label is orange, right? So this is the training data. So this type of huge data will be given. It's not just 4 rows. So each rows are basically, okay. So this column headings, except the last one, is called features, and all these rows, right? Each rows are called one of the examples for that, right? So now we are looking at what is a classifier, right? So a classifier is, there are a lot of other classifiers are there, but we are just looking at one classifier which is called a decision tree, right? So decision tree is very simple. You have a kind of a binary kind of a tree structure, right? And at each node, you will be asking what is the weight, right? If it is above 150 gram, you traverse in the left side, or if it is less, you traverse in the right side. And finally, you reach at the leaf nodes, and leaf nodes basically will say that whether it is an orange or apple, right? So in between nodes, you will ask all the features, whether the input image consists of these features, and you traverse based on that questions, and finally you reach the leaf level, right? So then you are actually building a model. So this decision tree that you have created from the training data is called a model, right? So and now the third thing is prediction, right? How you are going to predict it. So training is over. That means all the known data with images and labels we have shown to the machine, and machine has learned a classifier. We have a model now, right? And the prediction part is basically you give an unknown image, right? So the machine has not shown this image earlier, right? So that is called an unknown image. Unknown image in the sense it must be an apple or orange, right? So if you show that, it must be telling you, right? So this is the moment you wanted to check whether your model is going to predict it correctly or not, right? So there are n number of programming languages where you can easily do this, right? So I just maybe this is just a few lines of code used in scikit-learn. This is a framework. I will tell you other frameworks that is available for machine learning. Scikit-learn, you have to give only these things, features and the labels associated with, and all in numerics, right? So machine can only process numeric things, not text right now, right? And then you have a classifier you are calling it, and then this is the training part, fit part, and then finally you have to predict. So prediction, basically you are giving another, you may have to give another instance, right? So here 140, 130, and this is labeled as 1. That means this is orange kind of a thing, and this is 150 and 170. These are labeled as 0. This must be apple, right? And now what is it's going to predict, right? So you can input an unknown kind of a thing, and you can see whether it predicts it correctly or not, right? So this is the prediction part, and this is just a sample decision tree, right? That is been built from some other example, right? Given a lot of data, and so this shows you how the decision tree will look like. It will be a huge tree, right? It will be a huge tree. So that is how the prediction part goes, right? So now we have learned how a machine is going to learn, right? So let us recall whatever we have learned. The first thing was the input data, right? The second thing is we have to say what are the kind of features which will discriminate these objects, right? The third thing is learning a classifier. So to learn, we have to train the system and then build the model, right? And then the last part is the prediction part, where you will give an unknown kind of an image, and then you say whether it is predicting it correctly or not, right? If it is not predicting correctly, there is a problem with the model, right? Then you have to again come back and again train the system with other set of data, and then you have to see whether it is giving a correct result or not, right? So you have a lot of supervised methods called neural networks, naive-Bayes network, linear regression, logistic regression, support vector machines, k-nearest neighbor, random. These are all algorithms which are used to do supervised learning, right? Now we will see how an artificial neural network actually works, right? So artificial neural networks, as I told you, there must be an input layer and a hidden layer. So for time being, I haven't shown hidden layer here, and an output layer. So what it does is it takes an input, right? It's a numerical thing. So it could be some feature related to the object that you wanted to learn, right? So let us say this is 0.5 and 0.2. So it is given as an input, right? And this is called weight associated with this neuron, right? So 0.5 multiplied by 0.3, right? So this is the operation which is conducted here, right? And it is been added to this result of this. So 0.2 multiplied by 0.2, and this will be added together. Sum of this will be 0.19. So this is the output that is being that is going to be produced by this neuron, right? So artificial neural networks, if you see, basically have three operations. One operation is just multiplication. One operation is the summing of all the results, and then you are trying to predict something. Excuse me. Okay, so the weights associated with each labels can be given to so you can see here. So this is the weight associated with this, and this is the associated weight for this, right? So weight given for the subsequent nodes will be different, right? Based on what you actually wanted to train the machine, right? So we will see with one example. So this is the structure of the artificial neural network with hidden layers. And as I told you, in deep neural networks, there will be a lot of these type of hidden networks or layers, right? So this is the way in which the machine is actually trying to compute this, right? So the input variables will be there, then the weights are associated, and you will sum it, right? Multiply it with the weights and sum it, and then you do an activation function. Basically, activation function is related to the neurons, right? Whether the neuron has to give respond to the input, right? Each neuron actually trying to decide whether to respond or not, right? So this activation function is nothing but whether I have to respond or not, right? So this is the little bit mathematical formula related to this. So basically, it is a function, right, with the summation kind of a thing. And if you need, you can add some bias towards it, right? So let us see how we are going to do this for a house price prediction. Suppose you are in a new city and you wanted to buy a house, right? So input data that is there with you is the size of the house in square feet and the price associated with that, right? So price and size of the house in square feet is the input that is given to you, right? From this, you wanted to see a budget, right? You will have your own budget, right? And based on your requirements and all, you wanted to see how much price would be for that kind of a house, right? So for example, suppose I want a house in between, let's say 250 to 300 square feet, right? So somewhere around maybe 275, for example, right? So there is no correct price given, but you can see somewhere here it will come, right? So, but based on the preferences and all, so basically this is a linear kind of a model where you wanted to fit a linear line, and you can readily say that. So by just looking at this line and this line, you can say the price will be somewhere around this 3,000 US dollars, right? So, but you have to train the machine because the data that is given to you is a huge data, right? You cannot just plot it and just see, and you have a lot of other preferences as well, right? So, for example, you have the size, the bedroom, number of bedrooms, the pin code where maybe the representing the city, right? The wealth that you have, a lot of input constraints are there, and a lot of preferences will be there, right? So, for example, what is the family size? What is the walkability? What is the quality of schools that is available nearby? Lot of preferences will be there. So that will make the problem complicated, right? So, but with building a model using this neural network, you can readily build a model, and then you give your input, and it will predict the what is the price related to your maybe budget and all, right? So this is a simple neural network related kind of a problem you can readily solve, right? Okay, so there are unsupervised methods. I won't touch in detail these things, but earlier we have seen we have a data with associated label, right? So here unsupervised methods, we don't have labels associated with, right? We have only data. We don't have any labels associated with it, right? So how will you go maybe going to solve this type of problem, right? So there are methods called clustering and association. These are the methods to solve unsupervised kind of a problems, right? So this is a method where we can solve a bunch of data which doesn't have any labels, right? So K means is a method where we can solve a problem which is having nothing associated with labels, but we can cluster them, right? So group the data inside some clusters, and we can make a decision based on that group, right? Okay, so this is a picture where I just wanted to demonstrate how a deep neural network actually tries to solve a problem, right? So you have input as an image, so, right? This is a car image, right? And you have input neurons associated with this. So this image will be cut into small pieces, right? And corresponding numerical values will be given as an input to this, right, layer. And the first hidden layer, so these are hidden layers, right? So these hidden layers will try to identify most abstract kind of object from this given image, right? So this must be some kind of lines, right? Small slanting lines, etc. So those lines, fundamental kind of information will be extracted from this layer. The next layer will be trying to extract little bit more abstract information. That means it will try to connect these lines and try to make some triangles, right? Some shapes, right? And the third layer will learn to maybe higher kind of things, right? Like the shape of the car, right? And the fourth layer, subsequent layer will be having maybe trying to identify, okay, this is a car, right? And subsequent layers will learn it. And finally, you will be able to see what kind of a car is this, right? So this is a kind of a classification problem. So given a car image, you wanted to see which make is this, right? With this car is being automatically learned by the machine. So that is the beauty of deep neural network, right? So here we are not going to consider any kind of features, right? It will be given directly to the neural network, and it will be learning it by itself, right? Okay, now I will give you some idea of how we can go about programming deep neural network. So basically, there are a lot of frameworks available. Frameworks are basically the fundamental programming abstractions that is readily available, where you can go and start your programming, right? So TensorFlow, PyTorch, Scikit-learn, Keras, Torch, a lot of frameworks are available, and it is backed by giants like Google, Microsoft, right? IBM. A lot of giants are actually backing all these frameworks, but most of the frameworks are developed as an open source kind of a thing, right? So where we can directly go and start programming. Lot of machine learning related stuff will be already available there. You have to just call the functions and execute whatever you wanted to do, right? So that this will make any machine learners or AI programmers life easier. And nowadays everything is coming as a service, right? So AI is also coming as a service, and you can see that there are a good number of players in this area. Amazon Web Services is the most famous web service, and they are giving AI as a service, right? Azure is another platform, Microsoft's platform. BigML is another platform. Google Cloud is another platform, right? Data Robot, Baidu a Chinese-based company, a very famous company at par with Google in China, right? They are also giving access to frameworks which are available as offline. That means in the cloud, right? So there is no need to build up huge infrastructure for our own, right? There is no need to install software that is required to process AI or machine learning, right? Everything is there as a service. You have to just subscribe to the service and pay as per your use, right? So that is the idea, right? So there are a lot of programming kind of structures are available. You can see collab.research.google. So this is coming from Google Colab. So any student can start working in machine learning related things directly, right? If he knows Python language, then he can directly start programming in the Google's cloud platform, where he has to just log in and then start writing code, right? So similarly, Azure is from Microsoft. Kaggle is from Kaggle is a very famous organization which always conducts a lot of competitions related to machine learning. Amazon is there, then IBM is there, right? A lot of players are there in this. So let us see some examples of already built things. So let me see whether it will appear here or I may have to. So I will stop the sharing now and I will share the other window. Okay, so this is a convolutional neural network thing where you give an image, right? The neural network tries to create a similar type of an image. You can see how the machine is trying to learn, right? So let us see, let us give this as an input. So I have given this as an input and let me do a learning rate now. So you can see how machine is trying to figure out, right, what kind of an object is this, right? So it learns by itself to how to paint this image, right? So it tries to identify the boundaries, right? And maybe finer details later. It tries to figure out how the object is looking like. So you can see it is appearing, right? The image is about to appear. And you see that this takes a lot of time, right? It's a lot of computation power and time is required to teach a machine and run a model by giving an input and to create something, right, as an output. You see how the program is running and how it is trying to create the image. Yeah, so if you wait for some more minutes, I think it will come up with the image, same image, right? Okay, let me go to the next window. So let me leave this window. I will show you another window. So this is another application where we have classified sentiment, right? Sentiment that is there in the text, right? So let us see. You see, I have typed positive kind of text. So Veena attended the interview very confidently and her performance was excellent. The interview board recommended her for the job. You can see the result, 90%, right? So that means it's a positive kind of sentiment basically, right? So now let us just add some other maybe a negative kind of a thing. Uh, so you can see the confidence level is going down, right? You can see the sentiment is going down, and it is not 90% now. It is went down to 75%, right? So you can put appropriate text, and you can see how it works actually, right? So the next application is a very interesting application. You will see that. So this application is basically, it will take a lot of time, but this is very interesting application where you have a handwritten document, right? And this handwritten document can be given as an input to this machine, and it tries to learn the style of that handwriting, right? And now you give a text, right? A computer based text, and the machine will output, right? The same handwritten kind of a document, right? So maybe maybe you have Adharam, right? House, maybe property as a formal document, Adharam, right? So you can generate that Adharam. Mostly old things are handwritten kind of a thing, right? So you give a bunch of such handwritten documents, and then the machine can learn that style, right? And it can produce that kind of handwritten document. So it is maybe, okay, I don't have time to just demonstrate it. So idea is just you give a text here, then you choose some of the style, and then you say generate. So it will generate whatever sentence that you have written in that style, right? Okay. So there are other lot of other examples that I have given as links, so you can use it. I will share this slide so that you can go to a lot of exciting examples that is there, right? So I will tell you, natural language processing is basically the fundamental stuff which promoted, or most of the applications, successful applications are related to NLP, natural language processing. And now people has generated even language models, right? Language models, as I explained, the Google is translating something, right? So behind that, we have a natural language generator for that, or natural language model is being built, and that model is being used to generate the translated kind of a text. Now, the industry is in such a way, they have reached at a point where even people can generate text, right? You give some little bit of hints for a story. Now this model can generate a story for you, right? So that much confidence is there, right? So you can see there are a lot of natural language generator models are available. So like Megatron from NVIDIA, Turing NLG from Microsoft, GPT is an open AI kind of stuff. BERT is a Google model where we can generate languages, right? The machine is trained in such a manner that it can ultimately produce some text, right? So far, what we have seen is it is processing something, right, and giving some output. But here, it is producing something. It is maybe a story is being written by the machine itself, right? So we are approaching to that kind of a sophistication. So AI basically considered as a black box, right? So I told you different deep learning kind of a models where we consider this as a black box. We don't know what is actually happening inside. Inside, we have already know they compute some weights, do some summations, and tries to whether activate or not activate, right? These are the fundamental operations that's been done. But where it has been already, in which layer, which neurons are actually doing it, and what is the reason for that? That we don't know actually. So basically, AI is called as a black box kind of a thing, and we have a lot of problems with that, right? So one of the major problem is the bias and the unfairness related to that. So one of the example in 2015 or so, Google has released a image annotation application where if you give an image, it will annotate what is it, right? So some black couples, a photograph of a black couple was given, and it has been tagged as a gorillas. And Google already apologized for that, and they have maybe explained why it has happened because maybe of the data that is being given for training. So depending on the data, right, and what kind of data that you are giving an input as an input, the model will learn that, and the model will try to. And most of the time, it may not be fair actually, right? So in healthcare, for example, it has a long maybe counter things might happen. So we must be very careful in selecting the data and giving it for training and right. So those things are very important. So bias and fairness is very important, and people are going towards a thing called responsible AI, right? So we must be able to explain why AI models are producing this type of results. So this is very important, right? So this field is called responsible AI or explainable AI, right? So any model you can build, but inside what is happening, you must be able to tell or explain, right? So now I am giving you some of the pointers to further learn. A lot of stuff is there. I have selected and curated some links. So there are some good courses that has been already available there. Straight from Google, you can get a course on AI. Then in Coursera kind of MOOC-based platforms, you have Andrew Ng is a pioneering person in AI, so you can get a course from him, right? It's a free course. Then Upgrad is another MOOC-based platform. IBM is having another platform, and they have AI-based courses there, right? Another trouble people are facing is with deep fakes. Basically, you can. I think I should play this video. So I will just share that. I'm sorry for that.
Not stay in the cradle forever. It is time to go forth,
So you can see a person who is addressing, right, a group of people or a television show, etc. But now you can generate a video, right? A video where you can change the face of the person, right? So this is called the deep fake, right? So this is very dangerous, right? So I will take 2 more minutes and I will stop. Yeah. So I have co-authored a book on fake news. There are a lot of maybe techniques that has been discussed. It has been published by Springer, and Dr. Senthilnath was mentioning about a project, an international project, and this book is an outcome of that. So here I have contributed a couple of chapters where these type of stuff is been discussed. So how machine learning and deep learning kind of stuff is utilized for identifying fake news. So I don't have much time to discuss that. And India has started an initiative which is called the India Initiative AI for All. I encourage all the participants to go and register. It's a free kind of a stuff, and get a badge and certificate which is direct recognition from Government of India, right? So you can use this link ai-for-all.in, which is powered by Intel basically. And you will be maybe you have to spend some maybe 2 to 3 hours, right, just to listen to some of the text, video, etc. And then you have to answer some questions. So basically it will generate an awareness about AI, right? So it will give a certificate that you are AI aware, right? And another course, a follow-up course will give you another certificate for that. So I encourage you go and collect both certificates. It's very easy. You can learn and understand what is actually happening in AI field. So these are some books, very good books, just for it's not technical, a non-technical kind, but it's a very serious type of a book. You can go through it and you can read to understand more about the AI and how it is going to change our world. So these are another set of books. The last book is basically a technical book, which is usually used by computer science graduates to learn a course on artificial intelligence. But other books are maybe a kind of a general reading type of a book. So I encourage you can get a copy of these books and you can try to learn this. Right. So summary, basically, as I told you, we are at weak AI position, right? And most of the people were thinking that intelligence is just a computation, right? So intelligence is not computation. It is a kind of an emerging property, an emergent property, right? It will have only in a living kind of an organism, right? So I don't know how much time it will take to evolve and to make a computer intelligent, right? So that is the bottom line, and I'm stopping here. Thank you for listening to me, and if you have questions, you can just start shooting it so that I can answer.
Hello, sir.
Yeah.
Sir, good afternoon, sir. Thank you so much. The session was very informative, sir. That sentiment analysis project, sir, you shown in your one of the slide.
Yes.
Can we demonstrate it directly through online, sir? Can we find that URL of it?
Yes. I will be sharing the slides to Dr. Senthilnath.
Because it will be very helpful for understanding the concept, sir.
Yes, definitely.
Thank you, sir. Thank you, sir.
Yeah. So you can get it from the coordinator. Okay, the slides will be given to coordinator.
Good morning, good afternoon, sir.
Yeah, good afternoon. Yeah, tell me.
Sir, I have a question. Being a person from mathematics, particularly an optimization person.
Okay.
Sir, I want to ask that people say that genetic algorithms and these kind of algorithms are part of artificial intelligence.
Yes.
Well, actually, I have a question in my mind that the way intelligence is considered and the way you introduced, how we justify to categorize these algorithms to be artificially intelligent algorithms, like genetic algorithm, particle form optimization.
Yeah.
Like,
So basic stuff is if you are able to write a model, right,
yes.
which will learn something from the data, right? If you can claim that your algorithm or the model that you have built is able to learn something from the data, and maybe in future if you give some kind of an input, if it automatically tries to figure out something from the data, then you can call it is having some a little bit of intelligence, right.
Sir, otherwise means just the way in genetic algorithms, we tune the genetic algorithm parameters for
Yes.
optimization problems I am considering.
Correct,
So,
correct.
yeah, so that means by ourselves giving the parameters or ourselves trying to tune the parameters. So we should not say that it is AI algorithm, but if we tune them by learning, means the way AI learning is done, then probably it will be appropriate to tell that GA is now artificially intelligent.
Correct,
Correct, sir?
correct. Yeah. So, see, basically, what you have to concentrate on future data, right? So,
Yes.
whatever input that you have already given to this genetic kind of an algorithm, it will run by its own by maybe tuning the parameters, whatever, right? But after that, if you give, for example, classification of a gene sequence, right, using genetic
Yeah.
algorithm, right? If it performs by its own, right, with some intelligence, so that intelligence you have to create, right? Create from the training or maybe a training kind of a process, right? The optimization parameters has to be done by the machine itself. If it is doing that, definitely you can call it as an AI powered kind of an algorithm. Yes.
Thank you, sir. Thanks for answering this question. Thanks so much.
Sir,
Okay.
thank you, sir. Good afternoon, sir.
Yeah, please.
Sir, can you hear me? Good afternoon, sir. Just very good session we
Yes.
have. Just I have two doubts. Can we able to transcript our handwritten to by this technology, sir?
Definitely, there are a lot of work that has been done already, where you can write something on a tablet kind of a stuff, right? That will be coming as an input, right? And that will be translated into, or that will be converted into a machine generated kind of a text. In our department, we have done some work on machine uh, automatically translating Malayalam characters, right?
Oh. No, sir. We are having the without decipher our ancient scripts. Are, still, it is not deciphered. Can we input that script into that language? It can be translated into our find out the language and script as it is.
Definitely, you can do that, because even Google is able to even identify what kind of a language is already been input in the text box, right? You might have seen that, right? So this is able because Google has already trained something, right, with all these type of languages, right? So what you have to do is you have to collect ancient scripts, right,
Yes.
and then you have to train your machine, right, so that it can identify maybe future kind of a sentences that might have generated from these ancient scripts.
Can we find the language also? Because
Definitely.
so far there is a debate on ancient scripts or Indus scripts.
No,
Still, we are not deciphered that Indus scripts. Can we do by this technology? Can we get the language and script as it is?
no. If you have enough number of data, right, to train the machine, you need a huge amount of data, right?
Oh,
Then only you can build a model which will be used to identify that language, right? If you have that much of data, definitely you can build a model so that it can identify the language. So what I was trying to tell is, if you input a French sentence, right, in Google Translate window, it will say that it is French, right?
oh.
Yeah.
So already
And-
known language you can find out,
Correct,
but
correct,
not new
correct.
language. Sir, otherwise it
see-
is a threat to us, sir. If you put our name BH, it will fill the other part. In future, we forget to know our name itself. The artificial
Yeah,
intelligence is the other threat also we have.
yeah, even in Gmail interface, you have seen sentence completions, right? So these
We
are
use
actually
the natural intelligence.
no. These are basically on the training part. Basically, they have used a huge amount of data, right? So hello, how? If you write hello, how
How?
are you?
Or you
Must be
it will fill. Sometimes it without filling it will go, sir.
yeah. Sometimes it may cause some problems as well, right?
Yes, sir. Yes, sir. Thank you very much for your answer. Thank you very much.
Sir, hello.
Yes, yes, please.
Yes.
Sir, how artificial intelligence can be used, especially in natural language processing, sir?
Yeah.
Hello.
Yeah.
Natural language processing relation with artificial intelligence, sir?
Yeah, definitely. A lot of applications that we are actually encountering is from natural language processing. Basically, computer vision and natural language processing were the two fields we have heavily utilized to do a lot of applications, right? So whatever that I have just was telling to Bhavani madam was related to natural language processing, right? And I
Yes,
told
sir.
you about the generation of languages, right? So that birth model or the GPT model that I have just shown, which are models which can generate even stories from that, right? So natural language processing is a very fertile area. You can design a lot of artificial intelligence related applications using that. A lot of tools and techniques are available already.
Thank you, sir.
Yeah.
So, any other questions, observations, or add-ons to whatever Professor Santosh has been speaking? So, I'm sure all the participants have had very good inputs, as I can see in the chat box, all the messages of appreciation and thanks to the speaker, also for the HRDC for organizing this, I'm sure. But as we can understand, it is going to be an altogether different world. Right? That's what we say. And in fact, Santosh has been speaking on virtual learning environments and the next generation e-learning like adaptive e-learning. These are all, in the education side, the applications of AI. So, in fact, the government of India also has launched hashtag AI for all. You can go and see. Professor would have made a mention. So some questions I have seen something like, can you suggest some topics for PG level projects like that? So you can feel free to contact Santosh on his mail
So
ID.
my email ID is there. You can.
Yeah. It is santosh@qsat.ac.in, I think. Right? You can read his profile and interact with him, and see if you can collaborate with him for any academic or research activities also. Because webinars like this, you should provide such opportunities for networking and sharing of ideas and exchange of views. That's very important, right? Okay, because after all, if you have one good idea and I have one good idea, if both of us exchange, we will go home each with two new ideas.
Yeah.
But on the other hand, if you have one rupee and I have 1 rupee, both of us exchange, we will go home with just 1 rupee. But that is the idea. So I'm sure this webinar, particularly today's webinar and the other earlier webinars that we have organized, provided opportunities to the participants for such interaction and collaboration, because all resource persons have shared their mail IDs. You can feel free to interact with them and invite them for some such talks in your campus. If you think that these things should get disseminated to others in your campus, also in your group, you can feel free to do that. So now, if there are no more questions, I request all the participants to ensure that you're submitting the feedback form without fail. And I would like to thank all of you for your active participation. I could see quite a lot of participants very actively taking part. I would like to thank all of you, and I also would like to thank profusely Santosh Kumar for the very prolific and very professional delivery of the content to the participants for the benefit of them. I'm sure it has created a very good platform for all of them to know the basics and go and explore for themselves what AI can do to them as individuals, as academicians, and as professionals in the field of higher education. So thank you, Dr. Santosh, for sparing your valuable time this morning and being with us. I know, being the head of a center which takes care of the entire QSATS network, I know how busy you are in the morning hours especially, but you have spared your valuable time with us. I would like to thank you sincerely for that. So all my beloved participants, thank you so much for your active participation. And I do look forward to having you in our upcoming programs also. In fact, we will be giving a break for our webinars for some time because we are getting busy with our FIPs and refresher courses starting from September 6th. But in the due course, whenever there is because this 250 member enterprise account is there for us. So whenever time permits, we will be calling for webinars on similar topics like machine learning or IoT and other things. I do look forward to having all of you for our future webinars also. And we will be happy to listen to you. We'll be happy to get your views also on some other areas which require, because the other day, there are so many people who talked about this research and publication ethics. Some of them said, in addition to that, is copyright, patenting, IPR, these topics are also, we are looking forward. So we are also thinking of such topics for webinars in the days to come. So I do look forward to meeting you all once again in our webinars. So thank you very much to every one of you. Thank you very much, Santosh, right, for your valuable presentation and academic presence here. Once again, my request to all the participants, kindly ensure that you are submitting the feedback form without fail before leaving. And within a week's time, you will be getting the e-certificate to your mail, right? And in case there is any difficulty, you can call our helplines and send mails to us, right? We'll be very happy to respond. So thank you, everyone. Thank you very much.
Thank you, Dr.
Thank you.
Thank you, sir.
Yeah, thank you.
All the participants for your active participation.
Thank you.
I have already
Thank you.
slides to the coordinator. Please, those who are interested can request him to get it. Thank you.
Yeah. We are going to send. We are going to send. Sir. Right. Thank you very much.
Thank you.
Thank you, sir.
Thank you, man. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Bye, sir.
Thank you, sir.
Okay, thank you, sir.